Hey everybody, it's video note 6C. So we're going to be able to do molecular empirical formulas in percent composition. So percent composition. So any percent is always a ratio. And the ratio is always the part on the top and then the total on the bottom. So we can do percent composition of a compound. So we would take, there's two kinds of percents in here, percent of magnesium, percent of chlorine. So percent of magnesium, we would do the mass of one part. So I go to the periodic table and I get magnesium, 24.31, and that's grams of Mg, over the total. So I'd have to add up 2 chlorine plus a magnesium, 24.31, 35.45 times 2. And I find out that that is 95.21 grams total. Okay. So then to do a percent, I would that divided by that, and times 100 would be 25.53% magnesium. Okay, there's also another part in here, and that part is chlorine. So to do the part of chlorine, we need the total chlorine in the compound, which is the part of chlorine, and so that would be 70.90 grams of chlorine in the compound, divided by the total compound, 95.21 grams total, times 100, equals 74.47% of chlorine in that compound. Okay, that's one way of doing it. You just have to go get the masses from the periodic table. Here's another example. They're telling us that sulfur difluoride is 33.38 grams of fluorine and 28.20 grams of sulfur. So if we want the percent composition, we need the percent of sulfur. So we'd find sulfur, okay, 28.20. We don't have to go get anything from the periodic table, because it tells us that this is sulfur, right? But then the bottom is the total, so I have to add up the sulfur plus the fluorine for the total gives me 61.58 grams total. So then to do a percent, you divide part over total times 100, and we find out that this compound is 54.2%. Okay, 45.8% sulfur. Okay, well, this compound also has fluorine in it. So I'd have to take the 33.38 grams of fluorine, divided by the total again, it's always part over total, and times 100, I would get 54.2% fluorine. Okay, so percent composition is the part of the compound divided by the total, and we usually do it by mass. So if you're given mass in the problems, you don't have to use the periodic table, but if you're not, then you use the periodic table. Okay, so here's some samples. Find the percent composition of N in NH3. No numbers are given in this problem for mass, so we have to use the periodic table. So in NH3, there's one N, and N is 14.01. So it's going to be 14.01 grams of N in this compound. Now, percent is always part over total, so we have to add all this up, and we find out 17.04 grams total in NH3 times 100. So the percent of N is going to be 82.22% of nitrogen in the compound. Find the percent of H, percent comp of H. Well, in this compound, there's 3 H's, so 3.01 grams of H. Notice I have to use the periodic table because there's no numbers given. Still, the total 17.04 grams of NH3. That's the total. And to get a percent, you divide part over total, but then you multiply by 100 to get the percent. 17.78% of H. All right. So there's no numbers given, so use the periodic table to get grams. Go get grams. Right? Now, this time we have 25.0 grams of nitrogen and 6.5 grams of hydrogen. So we have some numbers. We want to know, is this compound NH3? So, well, let's do percent of N. So we'll say there's 25.0 grams of N in the compound, but then this plus this is the total. That's 31.5 grams of nitrogen and hydrogen. So that's the total times 100. We find out that this compound, this substance, is 79.37 grams of N. Wait a second. NH3, and we learned this in the last unit, that if it's a percent N and a percent H to be a compound, then it always has to be that. This only has 79.37% nitrogen, so no, this is not NH3. Okay, so percent composition help us find identity. NH3 has to have 82.22% nitrogen, or guess what? It is not NH3. This compound does not have that, so it's not NH3. Okay, so we're doing chemistry detective work. All right, formulas. Talking about detective work. This is a formula, okay? We'll talk about what kind it is. This is a chemical formula, all right? This is a chemical formula. Now, there are two kinds of chemical formulas we're going to be talking about. One is empirical, and that is the like lowest percent it can be, or the and then there's molecular. So these are formulas, right? We're going to figure out how to come up with these formulas. So there's science to doing this, all right? So what you're doing is you're going to use data. First step, step one. Step one, to find an empirical formula. Find empirical formula. Step one, turn grams into moles. Step two, turn those moles into whole numbers. Step three, turn the whole numbers into subscripts. Okay, so we're going to practice. Here's a substance, right? It has this information. We know how many grams of hydrogen, nitrogen, and oxygen are in it, but we don't know its formula. We don't know what it is. What is this, right? So step one, we're going to turn grams into moles, and you have to do this for all of them. So let's do H, hydrogen, 1.6 grams of H. Where am I going to go get the grams to moles? Is the periodic table. So there's 1.0 grams of hydrogen for every 1 mole of hydrogen. Where did I get this? Go get it, periodic table. Okay, and so then when I do that, I find out that that's 1.58 moles of H. All right, well, now let's do nitrogen. So I'm still doing step one, turn grams into moles. Nitrogen, 22.2 grams of nitrogen. I need to turn that into moles. So I go get 14.01 grams off the periodic table for every 1 mole of nitrogen off the periodic table, and I find out that's 1.58 moles of N. Okay, one more element, oxygen, in this compound. 76.2 grams of oxygen times 16.00 grams of oxygen for every 1 mole of oxygen. Where did I get this number? Periodic table. Okay, so I find out 4.76 moles of oxygen. Now, not done because I did step one. Step two is a new thing. We are going to turn these moles into whole numbers. So anytime you want a whole number, you got to divide something by itself, right, to get a 1. So I picked the smallest number of moles. Out of all of these moles, 1.58 is the smallest. So I would divide all of my moles by that smallest one to get one of them to be a whole number 1. So I say 1.58 mole H divided by 1.58 equals 1 mole H. All right. But then I'm using 1.8 as my divider because it's the smallest one. So then I have to do that with all of the elements. So there's nitrogen divided by 1.58 equals 1 mole N. All right. But since I'm using 1.58 as my divider, I have to do it for this one. 4.76 moles O divided by 1.58 is 3. So what I did was change grams to moles. Done. Moles to whole numbers by finding the smallest number of moles and dividing all of them by that as a factor. Okay. So relative to hydrogen, there's 1 mole of hydrogen, 1 mole of nitrogen, 3 moles of oxygen. Now I can use those whole numbers as subscripts. Okay. So the chemical formula of this stuff, the empirical formula, is H 1 time, because there's 1 mole of it, N 1 time, because there's 1 mole of it, O 3 times, because there's 3 moles of it. So this is the empirical formula. Woohoo! That's the empirical formula. It's a process we did all 3. Let's try it again. Sample of a compound is broken down into 13 grams of lead, 1.77 grams of nitrogen, and 4.03 grams of oxygen. What is the empirical formula? Okay, empirical formula. Step 1, change grams into moles. 13.0 grams of lead. Okay, change it into moles, so I go to the periodic table and I get 207.20 grams of lead for every 1 mole of lead. And I find out that that is 0.063 moles lead. All right, there's one element changed to moles, 1.77 grams of N. All right, so I got to change this to moles. Where do I get the 14.01? Come on, somebody say it. Go get it from the periodic table. Go get it from the periodic table. And I find that was 0.126 moles of nitrogen. All right, 4.03 grams of oxygen needs to be moles. So I use 16.0. I go get that from the periodic table. For every 1 mole of oxygen, I find out that that is 0.252 moles of O. All right, step 1, grams to moles. Step 2, we need to change this into the lowest number of moles. So I'm finding which one of these is smallest. 0.063 is the smallest, so I'm going to use that as my divider. 0.063 mole lead divided by 0.063, I find out there's 1 mole of lead in the empirical formula. All right, 0.126 moles N divided by 0.063, I find out, notice there's no units on this bottom number because it's just a factor to try to get things to whole numbers. Okay? All right, and then 0.252 moles of oxygen divided by 0.063. Here's what I find out, that there are 4 moles of O. All right, now we're ready to change. So we did grams into moles, moles into whole numbers. Now we can write those whole numbers are subscripts. So how many leads in the compound? 1. So I have a subscript of 1. I don't need it because 1 is assumed. N2, 2 moles of N. O4. So this is called our empirical formula. Woohoo! A lot of math, but look, now we know the chemical formula of this substance. Yay! Woohoo! All right, so there's 2 kinds of formulas, like I mentioned before, empirical and molecular. Empirical is what we just found. It's the reduced number of moles of each, lowest number of moles in each compound. Molecular formula is the real formula of the compound. Okay, so here's some examples. We just got done calculating empirical. Calculated on previous slide. Previous 2 slides. 2 slides. Okay, there's the steps for that. Molecular is some multiple of that. So molecular, like here's, we know water is H2O. That's its identity. Okay, it's also the same as the empirical formula because there's 2 H's and 1 O. But some compounds, their empirical formula is low, so 2, 6, 1. There's really 6 carbons, 18 hydrogens, and 3 oxygens in the identity of that, okay? This is the real formula, okay? Now, how do we know this? So a substance has a real formula, and then we can get its molar mass from this. An empirical formula would just be able to show us the ratios. All right, so molecular is some multiple of the empirical. All right, molecular is the exact formula of the substance. Water is H2O. Hydrogen peroxide is H2O2. Okay, so this is their identity. All right, but if you look at water, this is molecular. Its empirical is the same because it's a 2-to-1 ratio. The empirical formula of hydrogen peroxide is really HO. Empirical. All right. Molecular is what it really is. Empirical is a reduced version. Sugar is C6H12O6. That's molecular. That's its identity. All right. But its empirical is CH2O is empirical. Okay. It's some. So molecular is a multiple of empirical. Empirical is the lowest ratio, and it comes from the percent of each element. Molecular is real and some multiple. All right, so what does this mean of empirical? It could be a multiple of 1, could be a multiple of 2, could be a multiple of 3. So if the empirical formula of CH2 has a mass of 42.09 grams per mole, what is its molecular formula? Okay, so empirical CH2, molecular is 4.09. So empirical mass, C, 12.01, where did I get that? Periodic table, H, 1.01 times 2. The empirical mass is equals 14.03 grams for every 1 mole per mole. All right. So molecular mass is 42.09. And so we would divide it by the empirical mass, 14.03, and we find out that it's a value of 3. So the molecular formula equals 3 times the empirical formula. So it would be CH2 times 3, we'd get C3H6. Okay. All right, if the substance has an empirical formula of NO and a molecular mass of 30.1, what is the molecular formula? Okay, so this is molar mass. We need to find empirical mass. All right, empirical mass is nitrogen, 14.01, plus oxygen, 16.00. Empirical mass is 30.01. Okay. So then molecular mass divided by empirical mass is molecular mass 30.01 divided by empirical mass 30.01 equals 1. So the empirical formula and molecular formula are both NO for that one. It's the same. Okay? All right. So why do we care? So this bunny wants to know why. And those raccoons want to know why. So knowing empirical and molecular formulas helps chemical engineers design molecules, make life better, okay? It also helps us understand the identity of matter. Identify matter. What's it? What is it? What is it? Right? So to review, always go through moles. So that periodic table is going to be helpful. Empirical is a reduced formula. Molecular, find empirical with our step 1, step 2, step 3. All right. And then the multiplier is for molecular. Okay, so video note 6C. Can you determine molecular formula for a substance given the percent composition? We have to understand percent composition. We have to use percent composition to get empirical. We have to use empirical and molecular to figure out which formula is which. Okay, that's all I got for you. Peace out, peeps.